Hey guys, it's Bruce. Welcome to ConvoCourses podcast, and we're going to be talking today about application security. So we're going to wait a couple minutes here, bring some more people in. Application security. So the reason why I'm going to talk about this is that I've been on a journey to get another job, and looks like I got an interview. Looks like I got an interview. So I decided that I'm going to go ahead and talk about what that job most likely will be about. Haven't read the job description. It's going to be about application security, which is something I've done on and off over the years. Application security. Not my biggest, not the thing I do the most, but every now and then it comes up. And so this next job that I'm going to interview for real soon is it's mostly application security. So that's what we're going to talk about today. I'm just going to break down some of the highlights and all the main things that we should know about it, um, and some of my experience with it here and there, and some things I don't really have experience with or have very, very little exposure to. All right, let me get started here. I'm just going to go ahead and start with the slide deck. There we go. All right, we're on Facebook, we're on LinkedIn, we're on YouTube, and we're on TikTok. I'm going to keep it high level and just try to give you like the main idea of what this is all about. Application security. So let's go ahead and if you want, the link is in description where you can follow along with me. I've published all of the slides, everything you see here. You see it if you want to join more of a conversation about all things GRC, cybersecurity, or maybe you happen to be in this industry and trying to level up, trying to make a lateral change, something you want to get into, then I've been doing this for 20 years, and I give out free information all throughout the week. So got people contacting me about just basic advice, like asking basic things about how to get in this field or what to do about certain things. When I have time, I'll go ahead and help people out. So why do I do it? I mean, I'm trying to help people out as much as possible. It's hard enough as is, so I'm always just trying to help out where I can. And if you want to go a little bit deeper, I do have books, I've got courses, I've got stuff you can purchase that took me more time to develop, that obviously, I have to charge for it. But most 99% of the stuff I do is for free. If you follow me on YouTube, on TikTok, on all these different platforms, hell, even you follow me, sometimes I even give out free books. I'll release it for free for some time, or courses, I'll release those for free for sometimes. I got one coming out real soon called GRC Roadmap, where I'm going to be breaking down the NISTRMF 2.0 to show you how GRC is done in great detail. That one, I think I'm going to the first part I'm going to be releasing for free if you happen to follow me. So if you're interested in that, that's another one that you can join. All right, so let's get into this. It's already 12:13, so I'm gonna go ahead and go through the slide deck. Let me see who we got here. Not many people joining, but you can watch it later if you want. Okay, so what is application security? I'm gonna keep it real high level. Application security is securing code written in your organization, or if you write code for a business or mission, whatever, there's a way that you think there's things, best practices that you should keep in mind when you are writing code, or if you happen to be on a team where someone else is writing the code, there's just a couple things you should know to make it so that your data is secure when this thing goes out. Before it's even delivered, there's certain things that you can keep in mind. So that is what it's all about. It is the discipline of ensuring that the software applications are designed, developed, deployed, and maintained in a secure way using fundamentals, best security practices. That's really all it is. It's called AppSec for short. And like I said, I've had a little bit of exposure to it, but it's not my main. It's not the main thing I've been doing all these years. Mostly, I do enterprise type stuff, but it does come up. We have in different environments I've been in. We'll have like we'll have different tools that we'll use and different techniques. If we have a team that's developing in-house applications, or if you have a web application that's used externally or internally on our network, then you have to do some of the stuff that we're going to be talking about. So application security uses something called the SDLC, or the software development lifecycle, also sometimes called the system development lifecycle, software development lifecycle, specifically for applications, web applications, APIs, even apps on databases, small bits of code that are doing one function, one business, or a few different business functions. Okay, so let's keep it going here. So the role, if you happen to get a job doing AppSec, application security, you're going to be doing these three main things. You're going to be doing risk assessment and threat modeling, and that is identifying, analyzing, and prioritizing all the security risks and threats to the code that you're making or is being developed in your organization. You're going to be doing secure code enforcement. So your organization from the management level is going to push down some kind of things that absolutely must be done throughout the course of our development, software development. Things like, I mean, basic things, right? Like there's some things that you can't avoid, like identity and access management, for example, you know, authentication, the encryption. There might be some things your organization cannot avoid. So your organization will enforce those secure coding standards. And then there's code review and remediation tracking. And this is reviewing either manually or in an automated way, looking at the source code or looking at code that's already actually developed out there and scanning it, looking for different issues with it. It could be you're going to document those findings. You're going to assign severity levels to the tracking. So it's kind of like a full circle, right? Like you need to do risk assessments to figure out what the vulnerabilities are. You need to have best security practices where your whole organization knows what they're supposed to be doing as they're securing this code or to protect the environment, but then also doing regular remediation tracking. How are we going to fix? We know that this is the vulnerability. How are we going to fix it? Now let's document what has been fixed and maybe document things we can't fix. So those are the main roles that you're going to do as an AppSec professional. So more responsibilities that you're going to do, something called CI/CD pipeline security integration. So all this is kind of like continuous monitoring. If you're familiar with continuous monitoring, it's like looking at making sure the system remains always secure. You're always monitoring the traffic on your network, right? For CI/CD, it stands for continuous integration, continuous development, continuous development. So what you're doing here is continuously making sure that security is always being integrated as the code is being developed, as it's being designed, as it's being deployed and developed, is always a part. Security tools are embedded in the entire process of creating the code from the time that you start to the time that it's released. So that's the concept of CI/CD, and you as an AppSec person would be a part of that process. Web applications and API security is another important piece of what you're going to do. It's not just web applications, you know, where people are signing up. You have a form out there, people are signing up for your function or business or whatever, but it's also APIs. Like your organization might reach back to Google or use a Google search, or it might use LLMs, might use AI. That's like a big one these days. It might have an API that's reaching back, just using certain features of a whole nother organization, and that also needs to be protected. And you as an AppSec professional would be a part of that process. Those are things that you would monitor or be a part of And then data security tools. You're going to make sure that there's security controls that are implemented not only through the network, through the systems that they're using, the endpoint devices, but also in the code base. There's certain controls that need to be put into place, and those are done. They might have a different regulation where the controls are coming from NIST 853 or coming from 27,000 series, or there's different controls that the organization might have to use, and you would be a part of that as an AppSec professional. So another thing is tools. So there's a couple tools that you might use as an AppSec professional. One of them is called a static application security testing, or SAST. And there's different kinds. This is not one thing. There's many different brands of this, but all it's going to do is identify vulnerabilities without executing the program, like the source code. You're going to run this application to look at the source code and how it's the logic of how it's been created and how it's been built, to see if there's any kind of errors or something that could be breached. So that's one of the tool sets that you might use. Another one is software composition analysis, or CSA, not to be confused with security control assessors, but it's a different concept. It's software software composition analysis is where your code base is 70 to 80% going to be built based off of different libraries, different tools and sets that have already been developed. You might have some open source things in there to do things like change colors. Like, you don't want to write, if you're writing an application that has to, and one of the little features that it does is change the colors on the screen or something, you don't have to write that from scratch. You could borrow the code from another library and use that. And that's 70 to 80% of applications are using third party. They're using other code. So software composition analysis is tracing all those other code libraries and all the other source code you're using, whether it's open source or whatever, and making sure that those don't have vulnerabilities, and tracing their vulnerabilities back to something like the National Vulnerability Database, where you got CVEs or CWEs or whatever weaknesses that they're tracking, that have already been tracked, and you're pulling those in and making sure that we're accounting for all the weaknesses throughout our organization. So those are some of the things that you're going to do as an application security person. And I see you guys as comments and questions. I'll get to that in a second. I'm going to go through some of these to give you an understanding of what this is. All right, so another tool set that you might use is called secret scanning. And so this is looking for anything in the code base that might have passwords or any kind of sensitive credentials in it. You might be thinking, why the hell would somebody put sensitive credentials in the code itself? Well, it's not just passwords. It might be an encryption key. It might be a hash. It might be, it's not always straightforward like a username password. Sometimes it's one software needs to communicate with another software, and the only way it can communicate with the other bit of code is to use a secure key, or a PKI key or something, private key, or private key and public key. And sometimes what the developers will do is put that in the code just to make it easier. But unfortunately, if it's not encrypted, if it's not done properly, it can get hacked. Like if you can expose the code. Like you see this sometimes in web applications. Sometimes people will write web applications and it'll have secure code in there, that it'll have credentials inside of the code. And if you just look at the source code, you can find out how to hack it, from looking at the source code. So one of the things you'll do is secret scanning to make sure that there's none of that kind of code in there that might be exploited by somebody else. All right, another thing is called threat modeling. So this is a common practice, and it's a proactive way of handling threats. So what you're doing is, as an AppSec person, you would be proactively helping the team anticipate rather than just reacting to threats. You're going to help them participate and um, mitigate any potential threats before they can be exploited. So just if it's the basic way I can understand, I can explain it to you is to say, did I hit this button? No. And Ruki, thank you for that $10. I appreciate that. So the basic way I can explain threat modeling to you is to imagine the organization imagining what could go wrong. What could, when you ask yourself, what could possibly go wrong? You're actually asking that question. What could, and then you're taking it a step further and saying, okay, really, what could go wrong? What is the most likely thing to go wrong? And how can we prevent it? And this little wheel here on the screen gives you a better understanding of breaking this threat modeling down. You're going to define the scope, the system scope. Like, what are we trying to break down? Like, what threat? What is our asset? What actual asset? We're not trying to protect the whole organization. We are not looking at the entire network, right? We're looking at one bit of code that does one thing. What is the boundary of that? What other components is it using to pull in to do what it needs to do? We're focusing on that, right? So we're focusing on that scope. And then we're going to try to identify the threats that are going to threaten the confidentiality, integrity, and availability. Now, here they call it STRIDE, which stands for spoofing, tampering, repudiation, information disclosure, and I'm trying to not look at the screen, but and remember it off the top of my head. Disclosure information, and then elevation of privileges. But essentially, it's just protection of confidentiality, integrity, and availability. We're making sure that the data that we want to remain secret remains secret, confidentiality, making sure that integrity is in place. Nobody can infiltrate the data and manipulate it and send it on its way. And then, of course, availability, making sure that the data that we want available, like on a website or on a database, is available to the people who are authorized to see it. That's what STRIDE is basically looking for. Anything that violates our CIA, our confidentiality, integrity, and availability, or going through the STRIDE methodology, that is, we can identify those things as a threat. So we're going to define the scope of our system, like of our app. We're going to identify the threats that are threatening the CIA of our app. We're going to evaluate the risks. Like, what is the actual risk? And this is actually pretty easy, because if we know that our code is only within our network, then maybe something like denial of service is not really going to be much of a threat, because it's not exposed to the internet where you would get a denial of service attack. Right, so that would eliminate certain threats, but we might have a bigger threat of an internal threat. Maybe we know that privileged users are using it, and they're pretty savvy on the network. So maybe we know that an SQL attack, this system is more susceptible to SQL because we have a certain kind of database. We have a very smart group of users. So we know that they might know certain things. So that won't be a higher level of risk. So we're evaluating the risk based off of the scope, based off of the threats, and figuring out what is the highest, most likely thing to happen to this application that we have, right? And then we're going to define controls. Now that we've isolated what's the most likely threat that's going to exploit the most likely weakness, or the highest level of weakness with the highest level of exposure, we're going to define the controls. Controls are security features, right? And that might be easier. It might be easy for us because if we already have, like, say, a framework, it already has controls, and we would apply the applicable controls. And then validation. Once we have our controls in place, we've implemented them, we've thought about all of the most likely threat, the most likely risk, we have the controls. Now we're thinking, okay, let's validate our threat model and see if it's effective. Let's review our threat model and see if this is effective. That might include like a peer review. We might document this and make sure everybody sees it. We might even just go ahead and do a test run, put it in place, and then run a scan on it to help us to validate this thing. And then iterative, like that means we're going to go back and fix it if we need to go through and make sure it's tight. All right. So another thing you would do as an AppSec person is secure code reviews. You'd have a process in place to review the application. This is different from every organization does this differently, but they all do it in their own way. In organization I've been in, what they'll normally do is have some sort of change review board that'll meet weekly or monthly or whenever, or if there's a major change, and they'll put their heads together and they'll review they might review code, they might review how the first iteration of the test has gone, review the vulnerabilities. So they do it differently, but a code review would include a security person as well as the engineers who are actually writing it and all that kind of stuff. And they've got a breakdown of what you would go do here: a preparation phase, defining the scope, a automated analysis where you're running a scan tool to look at the source code, manual review where you have the highest level of weaknesses, and then you're going to manually review it and prioritize it, and then document and tracking. Like, we've documented all the findings. We know which ones are the most severe. Now let's have a plan of action to fix these things. How quickly can we fix it? Who are the stakeholders who are going to fix it? So those are the things that go into a secure code review. But every organization does it differently. Nowadays, one of the biggest risks you have to application security is APIs. API is where all of us are using it. It's kind of running in the background. So every app you have on your phone is running some kind of API where it's reaching back to another more powerful either database, or reaching into other code bases, or reaching to other systems across the internet and pulling in certain features. Like, think of like your weather app. If you have a weather app, there's a front end of the weather app, the UI, where you are clicking the screen or wanting to see the 7-day prediction of weather, right? Well, that app has an API built in it where it's reaching back to a database, and that database that's in the site in Wyoming or whatever will have all the accurate data, and that so your app is pulling that data in and then showing you, displaying for you whatever query that you wanted. So an API is an interface that allows different software systems to communicate with each other. In a nutshell. But the thing is, as an app security person, we have to be extremely mindful of this, because that little interface can be hacked. And one of the biggest hacks is broken authentication, where the two applications that are talking to each other have a weakness in authentication. So somebody could come in between and either read everything we're doing, or even change the data, or break that authentication where it can't communicate anymore. So we got to make sure that authentication can't be broken. And you'll do that with something like called OAuth 2 or JWT or something like that. There's different mechanisms that if you're using them, you're good. But there's other things like excessive data exposure. Some APIs are not built properly, so they'll send too much information. Like if you're doing like a transaction over the web, a big one would be like PayPal or something like that, some kind of payment app. I'm not saying PayPal is exposed or anything. I know something special. I'm just using it as an example. But if let's say a payment app had too much data exposure, right? It's reaching back to a bank, or it's reaching back to another financial institution, and it's exposing too much information. Of course, that is bad, right? That could leak sensitive information. So another thing would be lack of rate limits. Like when the data is going back and forth, there's a way where you could do a denial of service attack. If somebody could get in between, do a man in the middle attack, they could make it so that there's too many transactions happening at the same time, and it crashed the whole app. So there's different things that you could do to exploit API. And so API security is super important. If you're an AppSec person, this would be one of the things on your list of things to protect within your organization. And there's different tools and stuff to protect it, and you would be involved with that process. Here's something people have asked me about to cover, and I haven't done this one in detail. I kind of just mentioned it a couple times, but OWASP is super important. So this is Open Web Application Security Project, and it's exactly how it sounds. That's exactly what it is. It's very, very important because all of us are using in some way, shape, or form different applications all day long. And there's a top 10 of the most vulnerable, the most likely threats and risks to a web application, right? And there's aside from web applications, you've got mobile applications, you got APIs, now you have LLMs. All of these have a top 10 OWASP, but specifically for web applications, you've got broken access controls, where somebody could exploit access to a system. You've got cryptographic failures, injection attacks, and insecure design. And we're going to cover a couple of these. So broken access controls is just like it sounds. It's you don't have enough restrictions on what authenticated users are allowed to. They're not restricted enough. And you maybe you have authenticated users, but they're not restricted enough, and so they're allowed to do certain things. So an attacker, of course, is going to use that to exploit that weakness and maybe get more information or get access to information that they shouldn't. So this is a common web application vulnerability that needs to be protected. And then we've got some different ways to prevent those things. And that, as an application security person, these are the things that will be on top of mind for you. Injection attacks, this be things like Log4j attacks or like SQL injection attacks. This is where, if you've ever, all of us have been to like a page, you go to a page and it has like a little box, a validation box where you can put information or whatever. Well, there's certain codes you can put in there that might, if the software is not written correctly, you can put certain codes in there that will make it spit out information that you shouldn't have. You could break the application and it'll show you the whole database if it's not written properly, and that's an injection attack. Another one is cross-site scripting. This is where an attacker would be able to. What they do is they'll use if the site doesn't have proper validation, it allows an attacker to execute a script on the victim's browser. So then if they can get in between you're on your browser and you're trying to communicate with a server somewhere. If the browser's not written properly, the browser doesn't have certain protections on it, they can get in between you and the browser and then make you go somewhere else. And let's say that site that you go to, that they send you to, looks like your bank, but it's not your bank. It's pretty diabolical. But cross-site scripting, if the page isn't written correctly, then that's one thing. If you're an AppSec person and you are doing the application security of your organization, you're going to be looking at how are we deploying our websites? Can we exploit our websites? In what way? And then how can we fix it? What can we do to fix it? What is the impact to our organization if we don't have the proper applications? We don't have our APIs are not secure. Our LLMs, if we're using those, are not secure, being done securely. That's the kind of work that you're going to be doing as an application security person. And let's keep going here. Just a quick mention, Microsoft has developed a secure development lifecycle that has become more of a standard. More and more people know about this. And it's essentially making sure that all of your developers have training on security. It's making sure that they know about requirements, and that requirements are being put in place. Security requirements are being put in place from the very beginning. For design, you're doing threat modeling right away. So you're designing the application, but you're doing it with security and threats in mind. Thinking to yourself, okay, what could go wrong here, and how can we prevent it? And what's the most likely threat? That's threat modeling. And then we're going to implement everything we've learned, all the security features that we want to put in. We're going to thinking about the threat modeling and how can we prevent against it. and we're going to implement security from the very beginning. Verification, we're going to do things like penetration scanning. We're going to do source code scanning, all that kind of good stuff. And that is all part of Microsoft security development lifecycle. And let me see, I don't have too much going on here. There's a few really important pieces like this next one coming up, but there's not too much more here. And then I'm going to open this up to questions. All right, so another huge one is that we kind of already addressed is called CI/CD, security integration. So you'll see this come up over and over again in application security, and it's continuous integration, continuous development. And the way that I remember this one to keep it top of mind is think of continuous monitoring. You know, continuous monitoring is where we're continuously looking at security. We're looking at the logs. We're looking at weaknesses that might be in the environment. We're using SIEMs. We're using prevention devices, intrusion prevention devices, or intrusion detection devices and stuff like that. Well, with software, you need to have something similar. And instead of looking at logs, we're looking at continuous integration, continuous development. Thanks, appreciate that. Continuous development, which is from birth to death. We're integrating security features, security tools continuously throughout the process. We're always looking at the source code. We're always looking at all of the dependencies of the source code, right? We're looking at, okay, if we're using stuff from GitHub, if we're using open source software, are there any current known weaknesses with those code bases and libraries that we're using? Has there been a change to PHP if we're using that code base? We're constantly using all of these different tools, and they kind of use this thing called shift to the left. This is something that keeps coming up. And what they mean here is if you think of the development of code from left to right, like you're starting here on the left and going to the right, we're going to shift the security of applications to the left, meaning we're going to do it from the very first minute we even think about the code. We're doing threat modeling. We're implementing tools if we can, any kind of tools that we can use to automate the security process. We're integrating that stuff from the very beginning of our process of developing the code. So that's what this is all about. Integrating security directly into the continuous integration, continuous deployment, CI/CD pipelines ensures that security testing happens automatically within the code change, with each code change. And that also would include things like version control, building it in phases, deployment. Every aspect has security in it. We have tools throughout the whole process. And then we have a little bit more about some of the tools that you would use. And we kind of talked about this one, the SAST tools, static application security tools, and it includes things like SonarQube, check marks, Fortify. This one, I'm familiar with that one. And SCA, which includes things like OWASP, the dependency check. And there's a few on here that I'm not seeing, like I think Invicti, but that's like after deployment. There's a couple of different applications that scanners that will look at the application and look for known OWASP top 10 type issues, and then there's some that are looking at the actual code base, the actual source code before you even deploy it. Now here's one that's gotten really big is Kubernetes, and I hear Professor Black Ops talk about this one quite a bit. Kubernetes and cloud technology. Kubernetes is a cloud technology that manages containers, and software developers are using containers quite a bit. So container is an environment where they can quickly just start writing code. They don't have to worry about what version of Linux they're on. They don't have to worry about if they're on Windows or they're on Mac OS or whatever, they just get right into the container and start doing whatever. They don't have to worry about all this other stuff. They just get in there, start writing the code. And Kubernetes makes it so that you can quickly slide one in, start working in this container, get rid of it. Okay, blow it away, bring in another one. You can just quickly, and something else is managing. The Kubernetes system is managing everything else in the back end. But there is a security piece that has to, we have to clean up that mess. Like we have to make sure that everything is being done, like while they're in there messing around. And how do we secure it? Well, it's done by defense in depth. So we're going to use an approach where we're addressing all the layers of Kubernetes, from the container to the control plane, all the way to the infrastructure itself. And what we're going to do, we're going to be looking at the network policies. We're going to be looking at STIGs. Professor Black Ops says STIGs, role-based access control, image scanning, actually controlling the images, admission controllers, all these types of things we're going to be looking at as AppSec people. And you may have touched some of these things in your career. If you happen to be in cybersecurity, you may have touched one or two of these different basic security features. So another thing is cloud security. So Kubernetes is on cloud, right? So Kubernetes is a technology that's in Google, whether you're in Google or AWS or Azure. It's used in all of these different environments. And so cloud security as a whole is important. Cloud security uses something called the shared responsibility model, which means, if you think about it, it's pretty common sense. Like if you are using cloud, you are responsible for your data. So if you're using AWS, they can't control what you're doing with your data. You created the data. You're responsible for whether or not you're going to encrypt it, because maybe you don't want to encrypt it. Maybe there's a reason you can't encrypt your data, or maybe that you have to encrypt the data. Like you are responsible for that piece, but they are responsible for the infrastructure, like whether or not a module that you're sitting on, the actual hardware that's in Texas, right? They are the ones monitoring the actual physical security of that hardware, and actually maybe making sure that that hardware doesn't get end of life or something. They do that. So it's a shared security model, where, or a shared responsibility model, where you share this with the cloud cloud service provider. You're sharing the security of this. So what are you doing? You're doing things like, you as the user, least privilege. So you're only giving people the least amount of privilege they need to do their job. And network segmentation, using things like VPCs, subnets, security groups. Endpoint protection, if you need to do data encryption for data at rest or data in transit, you're using that. You might have to do continuous monitoring. So these are all basic cloud, and this is nothing new to IT and cybersecurity people. Like this is all the same. It's really the same stuff, but it is done in a cloud environment. So let's keep going here. And this is stuff we talk about all the time, so I'm not going to go too deeply into this stuff. I do notice that this is missing a piece here. This NIST cybersecurity framework is missing govern function. But yeah, anyway, so as an AppSec guy, you might have to know some GRC, because some of the requirements, the security requirements, and actual, we talked about doing this from birth to death, of making sure the application is secure. Well, a framework is one of the things that you might have to do. A framework might be something that you have to incorporate from the beginning of your application's creation to the end of it, to where you guys scrap it. And NIST cybersecurity framework is one of those. Another one would be NIST 853 controls, NIST 800. And I think Professor Black Ops here, who is he said he calls himself a NIST 800 bigot. Oh my, I will never for the rest of my life forget that. Oh my Lord, that's hilarious. Anyway, you got other frameworks. You got ISO 27001, which is the international standard. And this one right here, listen, ISO 27000 to 2013. They're on 2022 now. But that would be part of your job. SOC 2, you would know whatever framework or regulation that they're using. You would use, HIPAA, whatever. If it's healthcare in the U.S., you would use some of these things. And that's pretty much it. I've got a couple projects and stuff that you could use. And again, if you link in description below, you'll see all of this slide deck. But these are certain things you could do as an AppSec person to kind of sharpen your skills. I'm going to open this up to questions. And I should let you guys know the reason why I'm doing this is for selfish reasons, because I told you I've been on a journey to possibly find another job, right? Well, I got an interview, so wish me luck. And mostly the job is doing the stuff I've been talking about. So I figure the best way for me to polish up my skill set is to talk about it. So that's why I decided to talk about this particular topic this week. So any questions whatsoever? And I do have some exposure to application security. It's been part of the job from time to time that I've had to be a part of that change review board or whatever that we're doing for applications, or looking at vulnerabilities on applications that are in our environment, stuff like that. Let me see here. I'm on TikTok. I'm answering some questions here, seeing if there's anything going on here. Thank you guys for watching. I appreciate you. I'm going to start off with my questions and comments and stuff on YouTube. Now, Rookie, thank you for that $10. I appreciate you. It says, hi, Bruce. How can I move from GRC to vulnerability management part of cybersecurity? In my experience, Rookie, like, many of the jobs that I've done have, as a GRC person, have included vulnerability management. This job I'm in is a lot of vulnerability management. I would say 70% of my job, 75, is vulnerability management. I'm a GRC person working for the government. The last job I did, I wrote some stuff for a pharma company. So that didn't have any vulnerability management in it. Thank God. Vulnerability management is not easy, by the way. It complicates your job. It makes it way more stressful. I mean, they pay more, but you're doing way more work. You're doing way more work. It's more exposure to tech. It's more technical, I'd say. You're going to be getting way more exposure to things like scanners and risk management on the technical side of it, and control implementation sometimes. But anyway, so this current job, I have vulnerability management. I'm doing GRC. The pharma one, no. The one before that, I was a consultant, so we didn't really do vulnerability management there. And then back when I was working at NASA, that was a little bit of vulnerability management. But mostly we had a whole team that was doing that. But your question was, how do you, if you wanted to go from GRC to like full blown or include more vulnerability management? I would say if you have exposure to more tools, like if you put things on your resume, like the tools that are used for vulnerability management, like scanning tools or patch management tools, an understanding of vulnerabilities themselves, putting things on your resume like CVSS scores, CVE scores, an understanding of them would help you, because that's the kind of stuff that they need to know that you can do. But definitely patch like MECM, the Microsoft's implementation of patch management systems. Some of the tools that they use to do vulnerability management, and some of the methods that they use. If you put that stuff on your resume, you'll get more people reaching out who want you to do vulnerability management type work. And STIGs, that's another one that could help you out, because some organizations, especially in the federal space, they're using STIGs, and actually you could download STIG Viewer right now. You could download STIG Viewer and start messing around with it, you list that on your resume, you probably get picked up on a vulnerability management. But you could, if you're in cybersecurity already or IT, you can even easily make a lateral. It'd probably be easier for you to just be included in the current things that are going on in your organization who are doing vulnerability management. Get involved, help them out, see if there's a way you can like start helping them, and then you can put that stuff on your resume, and that'll start leveling you up. So if you do make a a change to another organization, they'll be like, oh, this person, they have experience with CVSS, or they have experience remediating controls, or they have experience with how to prioritize different weaknesses. That'll help you out. I mean, that's I'm just telling you what helped me out, like to get into that space. But to be honest with you, vulnerabilities are a pain in the ass. It's the biggest pain in the ass ever. Like my best jobs did not include vulnerability management, to be honest with you. Like, and when I think back to all my best jobs, they didn't have nothing to do with vulnerability management. I'm not even playing. I'm not even lying. I'm not. All my best jobs, like I would say my top 10, my top 5, top 3 best jobs was the pharma job, which was straight up technical writing, cybersecurity technical writing. Best job, coolest gig I ever had. Another one was when I was working with the Air Force Weather Agency, doing that was mostly documentation. I was writing cybersecurity policies. Another one was damn, I know I'm forgetting one or two. The teaching gig, I was teaching. That had nothing to do with vulnerability. Those were easy. They're much easier because vulnerability management is like a flood of new work. Like most of my hours, my extra hours in a week, over 40, is messing around with freaking vulnerabilities, because there's so many, and they nonstop. They don't ever stop, and some of them are emergencies. So yeah, I mean, it's I'm always going to be employed, but it's a pain in the ass, to be honest with you. Hope that helps. All right, let me see here. And I'm having some really bad problems with Stream right now. It's like it stopped working. Hold on, let me see. Can you guys still hear me? All right, it's working on TikTok, but okay. I don't know if it's frozen. Just let me know. All right, I'm on TikTok, which is still working. Somebody says, can you share the web page you are showing? Yeah, can you share the web page you are showing? If you're on TikTok, then it should be displayed below. I mean, what I'm looking at here below is, this is all it right here. Let me see here. Any tips on CMMC? I'm not a CMMC person. I would say, read the source material, which, I mean, you probably already know, but it's NIST 800 171, if I'm not mistaken. But I'm not a CMMC person. I know that a lot of the same controls are used. They're using the same controls as the NIST 800. A lot of the same controls. All right, let me see here. More questions on TikTok. Where does GitHub fit in all of this? So GitHub is a repository for code, and it's in the pipeline of development. Let me see if I can. So I know that I'm not a DevOps, okay? So I'm not trying to blow smoke or anything. I'm just telling you what I know. And what I know is I'm not, like I said, I don't do DevOps stuff. It's not my, I'm used to doing network security on large environments. And my exposure to just having one code base and mess around with that is a bit limited. I'm not saying I've never done it before, but it's not my bread and butter. You know what I mean? It's not the thing I do every day. Like, talk off the top of my head. A lot of times when I'm doing these streams, I don't have no notes. I'm just talking. I'm literally telling you guys what I do, like on a day-to-day basis, and that's so it's top of mind. This stuff I gotta have notes because this is not what I normally do. Have I done it before? Some of it, yeah. So the question was, where does GitHub fit in all of this? So GitHub would probably be part of the implementation of your. It would be part of the development and implementation phase of your application, because Git is a place where they have repositories of software. I mean, correct me if I'm wrong, guys. I don't want to blow smoke or anything. So Git is software that will help you to deploy software. It's software that helps you deploy it. I can't even talk intelligently on this. Git detection points. Okay. Pre-commit hooks, repository scanning, CD. Okay. I don't know. I can't speak on it intelligently. Anybody else? I'll read your comment. But from my understanding, GitHub is a repository that has all this different open source code. A lot of developers use it to help them develop code that they already have to implement into the code their current code base, and to keep track of what's going on. So they'll use, like, say, some kind of open source code out there. They'll pull that in, and then they'll use it to if it gets updated, they'll have to keep on track with that updated code. I know, I mean, it's pretty big because from my understanding, OpenAI and many of these other gigantic multi-billion companies are using source code from GitHub. They use a lot of open source stuff because they don't have to develop it in-house. So if GitHub has some incredible button that has been already written by some dudes in Germany for free, and then it's been out there for 10 years, and a whole bunch of brilliant folks are out there developing it, and that's something you don't have to develop in-house. They'll go to GitHub and grab that code for free, and then they'll use that person. They'll mess around with the source code, and then they'll implement it in their code, right? So in that process, like me as an app security person, I would be concerned with, okay, we probably want to run some code on it, like run a scan on that repository that they have, like on that data that they have, like source code. We would want to run some kind of source code scanner on it. And then when it was integrated into our main code base, we'd want to make sure that there was a way for us to keep versioning control. We'd also want to make sure that there's no way to exploit the rest of our code by using this open source code. So again, I'm not, that's not my forte. It's not my main thing, but those are some of the things that have been brought up from where I've worked before. It's like a server that holds different versions of software that is available publicly. Right. That's right. That's right. And why it's important is because I'll give you an example. I'll give you a real example. I was thinking to myself, man, I want to develop an app. This is real. I want to develop an app where I can just talk to the app, using text to speech to text, and then have it scan my network. I want to be able to say, okay, scanner, run an nmap command, nmap-i on my network, and give me a list of all the devices on my network. I just want to be able to talk to it. This was something I thought of. I was like, oh, that'd be cool if you could do that. And then I started like trying to develop it. And the easy part was the text to speech. I mean, it already exists. I mean, speech to text that's the easy part. But the hard part is developing a scanner from scratch. Because you'd have to develop a scanner, or I'd have to do an API to another app that somebody else wrote that's been around for 20 years, right? That would be the smartest thing to do, is to just, the smartest thing is to use somebody else's code who's already mastered it. And you could find that on GitHub. You can, hell, I could just use somebody else's code, and that would be the easiest way. So GitHub has a whole bunch of stuff like that people just wrote, you know, some frivolous application that, and they just put it out there. Why do they put it out there? I don't know. Sometimes they're a part of a larger organization, a larger group of guys who just put some stuff together and kind of been working on it for years. And then sometimes it's like they put some stuff out there to show, hey, here's my skill set. I'm trying to get hired. I wrote this code here, you know, go ahead and use it for free. So that's why you would put stuff out there for free, because you can't make any money off of something that, like, most of the code that's out there, there's no way to, like, how would you monetize it unless unless you are a part of a team and there's already a marketing team, they already have a way to monetize this application. So you just put stuff out there for free so you can get hired. Now that's one of the things, but so yeah, GitHub is just a repository of different software out there. And I've been talking for about 1 hour, but let me go through some more of these questions here. Let me see here. Ruki says, I want to take the Azure certification. Which Azure certification should I do first? The first one, if you don't know anything, is going to be the AWS CCP, or Cloud Certified Cloud Practitioner. If you don't know anything, if you're already like a cloud person, then it's a waste of your time. I took this certification. This is my first cloud certification, was AWS Certified Cloud Practitioner. For Azure, the first certification is going to be the AZ900. So AZ900, very similar to AWS CCP. AZ900 is the basic stuff. This is another one I took recently. That's the last certification I've taken, by the way. And it's pretty easy. I mean, it's just concepts. That's all it is memorization and concepts. And the features that they have, it's Microsoft's implementation of cloud and the fundamentals of cloud, as well as some of the products and services that Microsoft has. So that would be the first one you would want to take. But if you already know cloud, then you probably skip that one and go straight to. In fact, let me show you a breakdown that Microsoft has on their cloud certifications. They have like this really cool pathway, like a map that breaks it down on which ones you should take. And it's a really good way to visualize what Azure, hold on, 900 Azure certification paths. Yeah, okay, here, let me show you my screen real quick. Yeah, like this right here. And there you go. So you start off with this one right here. If you don't know anything whatsoever, like myself, you know, I'm pretty green to cloud, so I took this one right here, Azure Fundamentals. And then there's other fundamental ones if you want to be a data, I believe DP is data scientist. So if you wanted to be a data scientist or a data analyst, you take that one. You wanted to go the AI path, you take this one. These are all basic fundamentals, right? Starts off with this one. Once you're done with these, now if you're already IT pro, you're already doing cloud, you don't need this. You probably just go straight to these ones. So once you're done with these, like myself, you can go to this next iteration. So the next one would be, you want to go the developer path, the engineering path, or the administrator path. And then for, let me see, AI fundamentals, Azure AI 900, you would go from here to Azure AI engineer, which I'm thinking this is my next step, but I haven't committed yet, but I'm thinking after this, I'm studying for this one right now. I'm thinking about going super hardcore into this, but it kind of depends on what happens with this job, to be honest with you, that I'm about to take this interview for. So anyway, yeah, the first one will be AZ 900, and then there's other paths here. So I hope that helps you. My man, Professor Black Ops told me that the one I want to take, the path I want to take to make that real money, I think is this one right here. Architect, or which one was it? He either told me this one. Yeah, I think it was Professor Black Ops has this one right here. No, not he has AWS, my bad. So AWS has the same paths. AWS CC cloud paths. Let me show you that one real quick. I'm getting my certifications mixed up. They're very similar, but they definitely are different different paths here. So let me show you here. Yeah, so cloud practitioner for AWS. So this is the foundational, or just like fundamentals, equivalent of an Azure 900 or AZ 900. And then from there, you would take one of these. And I believe Professor Black Ops has this one right here, which is fire. And he has, help me out here. It's not showing on the screen. I think he has this one up here. Yeah, this one right here. Solutions. That one right there. So yeah, that's the path you can take right there. Not a bad move. Larry says we patch and update our APIs for our tools and systems, I believe, monthly. Yeah. Yep. Same here. Reading through comments here. What if I wanted to do a AI vulnerability management specifically for enterprise? Just a thought. So this is something I've been exploring myself, and it kind of brings me to OWASP has a breakdown of top 10 for LLMs, if I'm not mistaken. OWASP is the open source web application security project, and they have something for web applications, mobile devices, and recently for generative AI and LLMs. So let's just take a look at what Dormore Solutions is talking about here. And looks like, I mean, one of the first places I would look if I was looking to an AI vulnerability management would be this right here. OWASP Top 10 LLM Applications 2025. They've got prompt injection attacks, sensitive information disclosure, supply chain, data modeling poisoning, improper output handling, let's see, excessive agency, system prompt leakage. This is a big one. System prompt that recently happened. This right here happened to OpenAI like 5-6 months ago. And this happened recently to DeepSeek. Yeah, DeepSeek was really bad recently. Look it up. Vector embedding weaknesses, misinformation. That's a big one. Yeah, but see, they have a breakdown of all of this. And OWASP's not the only one, but there's probably the top one right now. I know the NIST AI, the NIST organization, it has some breakdowns of how to implement security features into an LLM. So yeah, there's some different places you can go to, but it's pretty early days for AI. Let me see if I have any more questions here on TikTok. Ken says, I did the SC 900, looking to take the SC 200 next. Ken, did you get any like traction after taking that one? I heard really, really good things about the SC 900. And SC 900 is that's Azure, right? SC 900 is something I've been toying, the idea I've been toying with, because I want to like a professional level, high professional level cert for. I haven't done it in quite some time, and I'm seriously thinking about going really deep in one of these, either Azure, AWS. Is the AWS security one worth it? Yes. So that's one of the things, Sultan, that my man Professor Black Ops said. Professor Black Ops is a high level cybersecurity GRC guy working for the IRS, and he's super deep into AWS. He's pretty deep into AWS, and he mentioned that AWS security is one of the best ones to do. And I think he's right, because all the lists, if you look at different lists, let me show you what I'm talking about here. Well, I'm lying. I don't want to lie to you. Azure, what? Let's top cloud certifications. Check this out. If you look at just top cloud certifications, right? This is from Splunk. You'll see like the same 4 or 5 certs kind of come up over and over again. Top 5 in that there's very marketable and they pay very good. And of course, you know, that's with you having some security under your belt. I mean, some experience and all that kind of stuff, right? It's not magic. So they're gonna want you to have some kind of experience and all that kind of thing. But if, let's say you have experience in cloud and you went ahead and got the AWS certified systems sysops administrator associate, this is paying pretty good, 105 to 139. And then you have AWS certified solutions architect associate. This is the one that Professor Black Ops told me to get. It's not bad. I mean, and it's in demand, because if you go to any on the job search site, they're looking for people who have this and experience, by the way. So it's not just the search that's going to magically get you this certification. And Cloud Security Alliance, this one I've heard of, but not as popular. AWS Certified Developer Associate, that's on here. Google Certified Professional Cloud Architect is on here. Google Certified Professional Data Engineer. And Microsoft Azure Fundamentals. That's a damn lie. This must be I must be on the wrong list. Now I'm skeptical about this whole list. Fundamentals is making, wait, let me see. How much are they saying this is making? 121,000. Come on, man. I don't know about this list. I don't know. Now I'm skeptical, man. I was looking for them to talk about the security, the AWS security one, and it's not even on this list. I don't know about this list. Let me keep going. The list doesn't have what I wanted, so now I'm like, I mean, it has fundamentals on it. I just don't. I'm not buying it. Let me see if I can find another one. 13 cloud certifications for 2025. I mean, I'm sure it'll be on this list. My point was what I was trying to bring, what I was trying to prove, which the first one is making me look bad here, is that most of the lists that I've been looking at had AWS security, and now I'm not seeing it. So I don't know. I'm pretty sure if you look through some of these lists, you'll see that specialized cert for security, and which is one of the reasons I was thinking about taking it myself, getting super deep in one area of cloud, because I did some research on it and it kept popping up. And now that I'm looking for it in front of everybody, I can't find it. But yeah, I think that one's good. A good certification. But if you keep looking through them, you will see like the same recurring certs. I am seeing associate come up, the AWS associate come up quite a bit. I bet you if I put cloud certification, cloud security certification, let's see, cloud security, of course, it's going to come up. Let's see, cloud security certification. I'm looking for like a list of cloud security certifications. I mean, I'm sure it'll come up on this list. So, but let's see. Maybe I don't know what I'm talking about. And they want me to sign in, so I'm going to do that. Let me see here. Yeah, I mean, there it is right there, but now I feel like I cheated. Vendor specific cloud certifications, AWS certified security. That's it right there. Yeah, kind of cheated though, because I got too specific on it. And Ken says, yeah, I would say that it's a fundamental level SC200 is better. Oh, SC200. Let me see. Azure SC200. Is that? I'm trying to remember where that one. Security operations. Oh yeah, security operations certification. Huh? Is that one about? Is that Sentinel or something? Like, are you learning about? Sentinel is a SIEM from Microsoft. I think Microsoft bought that SIEM. Security operation analyst associate. Yes. Okay. So this is. It must be like Sentinel, Defender. Yep. There we go. Okay. Yeah. Right. Sentinel, Defender for cloud, Microsoft 365 Defender. Okay. Right. It says it's intermediate. Yeah, this is another one I thought about. I've been thinking about. I'm still kind of thinking about what I want to do. I mean, for sure, I'm gonna do some Python. I'm gonna go deep on Python real soon, which is it's so weird because it's not a direction I've ever thought to take in my career. And now here I am thinking about doing more programming, which is it's crazy, but the signs are kind of pointing in that direction. Like I feel like that's the direction I need to take is to get more for the stuff I want to do, I need to learn more like logic, like programming or SQL. I need to go deep into those. I need to have it in my back pocket if I want to stay in this career field and continue to grow in the direction I want to. Then I have to get more technical because I'm not trying to be a manager, so I'm gonna have to be more technical, right? Like I don't have no other direction to go but to be way more technical. And if I want to do this, is like that's just the path that is leading me down because I want to do more AI stuff. That's not going to go away. So I'm like, man, I want to do that. I'm excited about it, which I haven't been this excited about a technology in a long time. And then most of the AI stuff is using Python. So, and then cloud, I got to go deeper in the cloud. So that's kind of where I'm at right now in my career as far as direction I want to go. Let me see here. Any other? All right, guys, I think that's it for me. Thank you guys so much for watching. I appreciate it. Thank you for that $10, rookie. That's great. Thanks you guys for hearing me. I'll let you guys know how it goes. This interview I have real soon. I really don't know, to be honest with you. It could go either way, but I'll let you know either way. Thanks for joining me on this journey. I started off by talking to you about like I'm gonna look for a job, and then boom, I got an interview real soon. But I'll let you know like what it is about this stuff here that you see on the screen. we'll see. We will see. I don't know. It could go either way. I'm not sure, but we shall see. All right, guys, I'm out on TikTok. Thank you guys so much for watching on LinkedIn, on YouTube. Thanks, Bruce. You think there's more money opportunities in staying more technical versus management? It's a good question. I think it depends on the job, on the role. I think management, like C-level, is gonna make you more money, unless you're developing your own stuff and you're gonna sell it or something. You're gonna make your own technology and then sell it, or make a company or something like that. I have to be honest, Larry. I think management is I think management is gonna make you more money. It's an easier path to more money, I think. Technical does make a lot of money. I mean, don't get me wrong, but management is just a straight line. It's just a more direct path to money. Like, it's just more, I mean, I have to be honest with myself. It just is. Because you could just become, like, you can go from management, upper level management, to C-level director type stuff. And those guys make, man, I mean, depending on the company, like you could pull down $200,000-$300,000, right, a year. You know, like you could easily, right? If it's a big enough company, hell, C-level execs are making like $1 million. But technical, I just don't know. I know that there are technical people making more than C-level execs. Okay, like if you look at, I know this sounds crazy, but OpenAI employees, machine learning, their best guys, supposedly got offered $100 million to go to Facebook. But these are top world-class machine learning guys who help build the biggest, most popular large language model in the world. So that's a 0.0001%, unicorn. Those guys are rare on planet Earth. They're rare human beings. So there's just not that many people that are like them that happen to hit every single lotto ticket on their way out of Stanford or out of their way out of Yale. There's just not too many people like that. So for the majority of people who have regular ass circumstances, or who are dealt a crazy hard hand to play, like myself, I'm not a unicorn. I'm not that guy. I'm just got to be honest with myself. I'm not that guy. So technically, I could probably pull down, like, if I did everything, if I marked every box, move to East Coast, right? I know all the boxes to check. I have to move to the East Coast, number one. I have to go to the office, number two. I have to have some kind of clearance, number three. If I did all of those things and want to remain technical, I'm sure I could pull at least 250. I'm sure if I did all of those things, I could pull like 250. Work in a small company, willing to travel, all that, I pull 250. I don't want to do none of that. I don't want to do anything I just said, except maybe work for a small company. I would do that. That'd be cool. Yeah, 250 technical. Management, hell, where I'm at, if I played my cards right and I played the game, I'm sure I could pull like 2 just doing management. I could just keep working my way up management and I pull like 2. But I see, but management admittedly isn't for everyone. To staying technical and upskilling can make you money and keep you doing the job you love. For me personally, I know it at some point I think I will do management like later if I'm still doing this later. Like I still like technical. I still it's fun to me. It's fun. Like it feels fun to do it. It's the whole reason I got into IT. Like I like to do the actual tinkering with things. And the management just does not I really just don't have any joy from doing it. Like I have no joy from doing any kind of management work. And it sucks to say it, man, because I know that's where the money is. I just don't like right now. I just don't want to do it, but I think eventually I'll have to. I can see it. I can see eventually I will have to manage a team, which hopefully it'll be a technical team. So at least. All right, guys, that's it. Thanks, Larry, for joining me. Thank you, Rookie, for that $10. Thank you, guys. I will talk to you guys later. Wish me luck. I'll let you guys know how it's going.